Hello, good morning. I hope you had a good night. We'll get started with class 3. The first thing I'd like to do is to revise some of the most difficult questions you had in the quiz last week. So for that, I'll be opening a few of the questions, the ones that had the worst scores. I'll first switch volume down here. I'm sorry. Right, so the first question I'd like to revise is what is the schema part of a URL about? So this is a question that has had the lowest overall score. Only 33% of people who responded to this question got it right. So to review what the schema of a URL is, we should go to the first class, go to slide 31, and here you got the standard definition of what a URL is, how it is conformed. I'll switch to my desktop in order for you to see this. Just give me a sec. There you go. I hope you're now seeing my desktop. I'll open my broadcaster software just to be sure. Yes, you're looking at my desktop. So now I'd like to comment on this question I just told you, right? The question in which you did worse in last week's quiz is this one I got here. What is the schema part of a URL about? So, well, the right answer is the schema defines a protocol by which the resource must be accessed. If we take a look to a general form of a URL, well, you see that here, right? This is the scheme of the URL, the scheme or the schema part, the scheme or schema. So this can be whatever protocol you want it to be. It can be HTTP, it can be HTTPS. I showed you an example in the first class, putting their mail to, and the browser opened up my mail client application. So it's just the protocol you put here. After the protocol, you put colon, // then authentication information, then goes the host. The host can be a domain name or an IP address. So this is the answer that was the most frequent. It says the schema defines the protocol and the domain name. Well, not all URLs have a domain name, right? The host can be either a domain name or an IP address. So that's why this answer is wrong, you know? And also, well, it's wrong because the schema just defines what's the protocol involved in the URL. You'd like to retrieve a resource by the URL. So in order to retrieve the resource, you need to specify a protocol. It makes sense. So you see here the correct answer. The schema defines the protocol. Okay, just the protocol. Then another another question I'd like to revise is, where was the World Wide Web created and who was its creator? Well, at first I got the correct answer wrongly stated in the item in the question. A classmate of yours let me know about it, so I could promptly regrade all the answers. I will translate. Esta pregunta, inicialmente marqué mal la respuesta correcta. Un compañero de ustedes me avisó así inmediatamente. Yo tuve el tiempo suficiente para cambiarla y hacer el regrading. O sea, todas las notas se recomputaron en base a la respuesta correcta. ¿Ya? Okay, so where was the World Wide Web created and who was its creator? Here you got like two pairs of options, right? It's about Tim Berners-Lee or Vinton Cerf, or the United States or Europe, right? So the correct answer is, well, the web was born in Switzerland, in the CERN, the National Lab for Particle Physics. This is a place in Switzerland, and the person who created the web or who led the project was Tim Berners-Lee. He didn't invent the internet. He invented the web, right? Sir Tim Berners-Lee. So it wasn't that difficult to get the answer right. About half of you who responded to this question got it right. So I hope this clarifies the answer, the correct answer. What is a CGI? Just 13 of you got this question. About 2/3 of people who responded got it right. Another third got it wrong. Little more than a third. So what's a CGI? I showed you this at the end of the first class. CGI is an early attempt at building web applications, right? So the CGI is basically a script that runs in the server, in the web server. And the problem with the CGI is that per each client request, a new CGI process has to be launched. Okay, so if you got many concurrent users, you can easily hog a machine, you can easily overwhelm a server, and immediately have sort of a kind of interrupted service, you know. Puedes votar un servidor web con CGI muy fácilmente porque consume recursos y por cada cliente que se conecta a un servidor hay que crear una nueva instancia del CGI. So it doesn't scale well. It doesn't scale well. Here's the correct answer. CGI is an early application technology, web application technology that does not scale well and is commonly based on programming languages and technologies that are hard to maintain. Well, that's the second part of the answer. Indeed, CGIs were written initially in a language, a scripting language that's known as Perl. So a script could contain Perl, SQL, and HTML, all three languages inside a script, so that can make it very difficult to maintain. You know, I emphasize and I say CGIs were commonly written in an obscure but powerful programming language, Perl. Okay. So then it should be now clear what the correct answer was. And finally, well, this question was answered by 16 people. About 3/4 of you got it right, but I'm concerned about the quarter who got it wrong. So what kind of message does an HTTP server send back to a client after handling its request message? If we see about HTTP, also in the first class, you'll see here the basic interaction, right? Here you got an HTTP client, here you got a server. So the client will always send request message to a server, and the server will respond with a response message. See, I was asking you to remember what this basic interaction was about. So it's not about the status code. The status code is part of the response, right? There's an example right next to this slide. So here you got a response, and that's the status message of the response. A post message, well, a post message is a kind of request message. Here you got a request message, which has the post verb at the beginning here. All right, so I hope that makes it clear as well. Well, the good news possibly for you is that, well, this week we won't be having a quiz, but we will next week. So prepare for next week. Study the contents of class 2, also this class, okay? We'll get started with this class right now. Just a moment. Okay, so yesterday afternoon, I left an introductory video to Ruby published on Canvas. I hope you watch it. It can facilitate you understanding any of the code you'll see in this class. Also, well, there are the slides upon which the video is based on. These slides are published also in Canvas. If you want to follow this class, you can either watch the screen, or you can watch this video stream, or you can open your slides that are available on Canvas. Okay, so I'll just get started with Ruby on Rails now. I'll introduce this technology we'll be using almost the entire semester, for the entire semester. So Ruby on Rails is known as a web application framework. A web application framework provides the foundation, the skeleton upon which you can build a robust web application, okay? It's based, of course, in the Ruby programming language. Rails is not part of the Ruby language, but it is part of the Ruby ecosystem. That means that it is a technology that's based on Ruby that can be used with other Ruby technologies. And, well, a variety of non-Ruby technologies as well. Because it's a web development framework, it's compatible with web technologies anyway. So Ruby on Rails is free software. That means that it can be freely distributable, freely studied, freely modified. It is distributed with a very permissive license, which is the MIT license. It is a license that will allow you to commercially exploit the software, modify the software, and repackage it. You name it. You can freely do almost whatever it is that you want to do with the software. And it could be interesting if you have a look at the MIT license anyway at some point. So the intent of Ruby on Rails is to facilitate accelerated, rapid development of web applications. Instead of starting from scratch, writing a script in Python or Perl or even Ruby, you got a complete infrastructure that will make very easy for you to get started. Get an application running in minutes, possibly a very minimal application, possibly running in a couple hours. It brings a lot of automation into the development process. We'll cover that with regard to how data is handled today. It can address some non-functional requirements which are very necessary nowadays. Performance, security. We could also name a maintainability of the software. The software will remain quite maintainable if you adhere to the good practices. And lastly, there's plenty of quality documentation available. There are possibly thousands, tens of thousands, hundreds of thousands, or even millions of posts in Stack Overflow. So from now on, when you start having some trouble with Ruby on Rails, it's most likely that you'll find solutions on the fly by searching Stack Overflow, also by asking me, asking the TAs. So there's plenty of help available. I'm giving you here sort of a reminder on what ModelViewController Architecture is about. It's likely that you already saw this in the object-oriented programming course. When you got an MVC architectural style, the application is basically split into 3 layers, we could say. There's a layer that will handle application data. And that layer, we call it the model, right? So the model will handle application data. It will handle all necessary rules to validate the data, to all the logic that's necessary to store the data in the database and recover the data from the database. Then we've got another layer on top of the model layer, which is the controller. So the controller will contain application logic. For instance, if you'd like to authenticate a user and log the user into your web application, then you'll have a controller that will handle the sign-in request, right? You'll have a sign-in way into the application, and the controller will, for instance, look for a model matching the username and will try to authenticate that user, right, by using the password. So the controller will implement application logic for different scenarios. You got data and you got application logic. So application logic is implemented by the controller. And lastly, you got the view with which the user interacts. So the view will show dynamic content based on data, based on what's in the model layer. So the controller will query the model layer for model instances and take the view and populate the view with model data. And that's how you get a web page that's entirely dynamic, that can be generated on the fly by the server, by the application server. So how does Ruby on Rails implement the ModelViewController architectural style? We see it here, right? Below, we got the web browser. We got a user on the web browser. Either it can be a mobile web browser or a desktop web browser. And there's a component in Ruby on Rails, which is called the Rails router, that will receive the request from the web browser and will decide which application logic component, that is, which controller will handle the request. There can be many controllers in your application, possibly matching different aspects of your application. User, for instance, registration and authentication. There can be, if you got an e-commerce application, then perhaps you got inventory, perhaps you got checkout, perhaps you got many workflows and processes involved, and you got controllers for each part of the application. So the Rails router will forward the request to a controller. The controller will conduct all the necessary queries on the models and will instance a specific view with which to send a response back to the browser, right? The response back to the browser, recall that it has a header and it has a body, right? The body must contain some representation. Either it can be HTML, it can be another format we'll see later that's called JSON, it can be XML, it can be, the response can be based on many different languages. You know, the body of the response for our you know, examples here, we'll think about the response being HTML, right? So the controller will send an HTML response back to the browser, and the HTML response is basically a view, a Rails view that gets rendered with data that is stored in the model, and the controller will do the integration among the models and the views and send the view, rendered view, back to the browser. So that's the flow there is in Ruby on Rails, and that's how Ruby on Rails implements the MVC architectural style. So now I'll head to the chat and see if you got any questions so far. Okay, so there are no questions so far. I'll now explain to you in more detail how the Ruby on Rails architecture works from a dynamic standpoint. So here's the dynamic perspective of the common use case in the architecture, right? We got a web browser, Firefox. In step 1, Firefox will send a request to the Rails router. So the browser would like, actually the user is interacting with the browser because the user wants to see what users are in the application, right? So the user wants a list of the users that are available in the application. That's what the request you see here, /users, is about. You want a list of the registered users. You want a list of the resources, the user resources that are available. So the Rails router will take the request and will handle the request by calling the appropriate controller. In this case, it should be the user's controller, the controller that handles users, right? So the user's controller will then execute step 3, which is going to the model. The controller will ask the model layer for all users that are available in the application. It will tell the model, hey, you give me all users. You can see that in between steps 3 and 5. You see user.all. Well, that's a syntax we'll cover in starting this class. We're basically asking the model layer to give us all the available users there are in the database. So the model will execute step 4, go to the database, conduct SQL queries, get the users, and return the users in step 5 to the controller, right? So in step 6, the controller will take a view to display all of the users. The controller will take that view and populate that view with the list of users that got from the model. And then the view will return HTML to the controller, which the controller can in turn send back to the browser in step 8 as HTML, right? So that's the dynamic perspective. This is how the different elements relate to each other and how they interact whenever the user sends a request to the web application. And now, yes, now I'd like to see if you got any questions. Okay. I think you're coping with this explanation reasonably well up to this point. So we'll see about some key principles in Ruby on Rails. These are a couple of principles that are very important to have in mind. There are two key principles that are always present when you develop with this technology. The first principle is convention over configuration. That means that our preferred ways of doing things, if you fail to comply with the conventions, that is with the preferred way to do things, this will often result in errors, unintended results, well, and a lot of pain and suffering, because many times you make a mistake without noticing, and you spend at least an hour or a couple hours trying to figure it out, and it's all about some variable you named wrongly, yeah? Some variable that took a wrong name, or even a method that maybe you named wrong, or because conventions involve a lot of naming practices, as we will see. And the second principle is the dry principle. Don't repeat yourself. That means that you won't be repeating your code all over in your application, right? So this is very common in the case of controllers, for instance, or in the case of models. If you got two controllers that do the exact same thing, then there's something wrong you're doing, right? If you got repeated software, repeated pieces of code all over your application, then making a change on one piece will mean that necessarily you need to do the same change on other pieces that are the same as the one you're changing, right? So you're working unnecessarily, updating many different pieces that do the same thing, and that makes no sense. So the formal definition of dry is every piece of knowledge in the system should have its single, unambiguous, and authoritative representation. That means that any system behavior should be implemented in a single, unambiguous, and authoritative representation, right? If you got a controller for users, then you don't want another controller for users, for instance. So let's see about the data layer or the model layer in Ruby on Rails. How does it work? How can we perhaps build our models, or how can we specify our models? Well, ActiveRecord, as I just mentioned, is the M part of the MVC architecture. That is, it is a model. It contains business data and the associated logic that is necessary to query that data, to update that data, to perform the basic CRUD operations on the data, basically. So objects can carry both the persistent data and the behavior. For instance, if you need to validate whether an object contains the correct data for its fields, the validation logic is implemented in the model layer. That's behavior of the model. Also, the models can respond to, we could say, events, pretty much like database triggers. That means when a model is updated, it can do stuff. When a model is created, after the model is created, it can do stuff, whatever you want, depending on the scenario, of course. So ActiveRecord, broadly speaking, is an object relational mapping ORM framework. That means that Ruby objects, Ruby models, are mapped to tuples in a relational database table. Okay, that's the basic concept behind the ORM framework. So the properties and relationships of the objects in an application can be easily stored and retrieved without writing SQL statements directly. What you do is to write object-oriented code in Ruby. So for this to work, there are many conventions that we have to follow very carefully. Otherwise, our code will break, our database won't work correctly, our model layer can fail. So what's the first convention we'll introduce? The first convention we'll introduce is pluralization. That's how it's called. So ActiveRecord is very strict on model naming conventions because the definition of a model in many cases will require the creation of a table in the underlying relational database schema. For instance, we've got three models at the right. We've got suppliers, we've got accounts, and we've got account histories. And you see in each case, the supplier's database table corresponds to a model which is called supplier. You see the model is in singular and the database table is in plural, right? You see account history, which is another model. It's a model class. You see the classes below. You see the class for supplier, the class for account, you see the class for account history. So there's a convention that tells that the class name is in singular form, and the database table name is in plural form. So naming conventions have to be strictly followed. When you name your model, it must be singular. The model class will have a singular name and it will be mapped to a database table with a pluralized name automatically by Ruby on Rails. This is what we call pluralization, finally. So there are a few caveats about pluralization. Pluralization will work well in English, even with irregular nouns such as man. The plural of man is men, right? So if you switch languages and you use Spanish, pluralization won't work correctly. The Ruby on Rails pluralizer doesn't know how to pluralize Spanish. It only knows how to pluralize English, right? So always code in English Okay, don't make mistakes. Well, if you make mistakes, you can roll back. You can simply eliminate your model and create another one. But it will save you work and hassle if you always code in English. So there's another convention which is about case, and that's about, for instance, lowercase, uppercase. It relates to the table that there's at the right side of this slide. Here we got at the left column different case types, and to the right some examples. So for instance, we've got a variable called some awesome var, right? Some awesome var. That's a string with a variable name. Even it has, well, it has spaces. So then we'd like to interpret that using different cases. Below you got camel case, which perhaps you used in C#. You got some awesome var, that's camel case. Then you got snake case, which has the same 3 words but concatenated with underscores among them. Then you got the kebab case, which instead of the underscores has simply dashes. You got the Pascal case, which is quite like camel case, but with the difference that the first word has the first letter in uppercase. And finally, you got the uppercase snake case, which is all letters in uppercase with the underscores joining the words. So you got these many different case types in programming in general. So in Ruby, for class names, we use the Pascal case. Okay, the Pascal case is what we use to name classes. To name database tables, the snake case is used. To name code files, to name files, Ruby code files, we use the snake case. So take a note and remember this, okay? Also, for variable names, we use the snake case. Okay, so if we got a book club model, the book club model written in Pascal case will map to a table whose name is in snake case and in plural form, okay? Here are another few examples. If you got article, the model class is article, the table name is articles. If you got line item, which is in Pascal case, you see there line and item with the first letter in uppercase, then it converts to snake case and pluralizes the second word, line items. You got deer, deers. You got mouse, that's an irregular one. You got mice, mouse, mice. You got person, you got people, so that's irregular as well, right? So I insist, this works well in English, it doesn't work in Spanish. So you can get your code easily broken if you start naming models in Spanish. Good, so there are other conventions as for the naming of the columns in database tables. For instance, if you are writing a foreign key, you got the singularized table name underscore ID. The underscore ID at the end always must be present, okay? For instance, if you want a foreign key to the items table, you need to specify a foreign key called item ID. If you want a foreign key to orders, then it's order ID and so on, right? Ruby on Rails will always create a numeric primary key, which is called ID, and which auto increments each time you create a new model instance. I'll go back to the questions to see if you got any. Okay, you're still processing the info. That's good. We'll cover a few examples in a few minutes. So when you create a model in Ruby on Rails and the table, the corresponding database table is created, the table will have some columns created as default. There's a column that's called created at. That column will record the entire timestamp, that is the date and time in which the model was stored into the database. The time when the record is first created. Then you got another column that's called updated at, and it is automatically set to the current date and time whenever the record is updated. And then you got another column that holds the count of number, the number of of objects that are in the table. Table name count is basically a quick way to know how many records there are in the table instead of running a query on the database that will count. The query that counts takes some time, so it's best to have some cache, storing the total number of items there are in the table. Then you got, for synchronization, if you got transactions, concurrent transactions, and the need for synchronization, there's a locking mechanism, optimistic locking mechanism, which uses another column. I'm giving you a definition of what optimistic locking is below. You can even check the link I'm giving you if you want to look into it into more detail. Right, that's I'd say knowledge that belongs to the database course rather than this. So I won't be making too much emphasis on locking anyway. But I suggest that you take a look to understand it, okay? There are also columns to store information about associations. Associations, will cover them further in this class. Associations are ways in which we can relate one model to another, right? So there are many different association types, for instance, depending on the cardinality of the association. And there are associations that there's an association, a particular one, that will allow one entity to relate to one entity or model to relate to other entities, such as in the example I'm giving you below. Polymorphic associations are a means for relating a model to other models. For instance, if you got a review written by a user, that review can be for a restaurant or it can be for a film. It can be the same data you're storing. However, the object can relate to two different entities, and that's possible to implement it with ActiveRecord, the model layer of Ruby on Rails, ActiveRecord. So after having a look at these basics about the ActiveRecord component, the model layer, we'll create a blank Ruby on Rails application. If you got Ruby installed on your computer and you already got perhaps Rails installed, I can show you how to install Rails. It's fairly easy. You create a blank application by running this command on your terminal, on your command line. You simply type Rails new and you name your application. It is customary to write the name of the application in lowercase and append the word app. Here are some examples: tickets app, store app, registrations app. So your application directory is automatically initialized as a Git repository, right? So if you'd like to work with GitHub, it's quite simple. You create your repository on GitHub. You configure your Rails application source control with Git to point to the repository just created with GitHub. You basically configure the remote parameter on the configuration of your Git repository. And if you need help with that, sure, we can give it to you. It's simple to do. All right, so we can just try that. You can check what version of Ruby you got if you type Ruby space dash short V, me corta. So I got Ruby 261 P33, which is from early 2019. It's a little dated, but well, it shouldn't give any problem whatsoever. Easy to update, but I'll stick to the stable 261. So okay, if I need to create a new application, it's Rails new, and well, I got an example application in this course, which is the tickets application. So a lot of output comes out. It's telling us what it's been doing. It's creating a lot of files. You see, it creates a git ignore file. It runs git init. That means it creates a git repository in our folder, in our directory, and also it starts creating all of the application code files, which are initially empty for the most part. So you see there are many folders, there are many directories that get created. There's an app directory that will hold your own development. That's the application code for the most part. Then you got a configuration directory that is necessary to tinker with when you want to deploy your application to a production environment, to a staging environment. Even for development, perhaps you would like to tweak some of the parameters that are available in the configuration files. Then you got libraries, you got a public folder with static HTML pages, such as error pages for internal server error or not found. You got a testing infrastructure for your application. You can have some automated tests running on your models or running on your controllers, right? You can have some integration tests that can test many different parts of the application altogether. So there are plenty of features that you'll be knowing about incrementally. Well, getting started with this part here with app models. That's the first part we'll see, app models, right? There are many other parts such as views, right? Such as controllers, okay? So we'll take it easy for now and start with the models. You're looking here at this list of dependencies that need to get installed. There are many dependencies that are required by a Ruby on Rails application. You see, for instance, this action view, this is the view part of Ruby on Rails, the view part. This action pack, well, this is also part of Rails, and it's basically utility functions. Okay, you got active job, which is for asynchronous jobs. You got the active model, which is what we'll be seeing along with ActiveRecord, active model and ActiveRecord. You got active storage for file storage in the cloud or local file storage. You got action mailer to send emails to users. You got action text, which is for rich text support in your application. You got many other dependencies for testing. You got dependencies for deployment. You got a web server here called Puma. Puma is actually, it acts both as an application server and as a web server, and we'll see the difference among those later on in the course. Sprockets is to package your application deployed to a production environment, for instance. Well, you see here, there are many different dependencies that are used. So, okay, then some other processes are run before your application is ready to be run for the first time, or perhaps if you'd like to implement some first ActiveRecord models, like we'll do in a few minutes. So Webpacker successfully installed. Okay, it installed all of the dependencies. We're using here Rails version 6. So the amount of dependencies it ever increases from Rails to in each successive Rails major version, the number of dependencies is more and more is bigger, grows bigger and bigger. Will these conventions be evaluated in all of the future labs assignments? Well, if you don't follow the conventions, it's most likely that your code will break and your application won't function, right? So it will be evaluated either directly or indirectly. Indirectly in the sense that your application might not work if you don't follow the conventions. When I do the command, my last thing that do is run bundle install local and run bundle exec spring bin stop all. And I don't know why you're doing that. Is it that your Rails new command is running those, or are you running those yourself? I'm not getting it right. But anyways, that's because, well, I got already, if you watched the other video I uploaded yesterday about Ruby, there's a part in which I explain how the gem ecosystem works, how packages are distributed. There's this utility called gem. I can list the gems that are available, and I've got all the necessary gems already installed. So that's why I could create my application with no hassle at all. I got my gems already installed, all those that are necessary by Rails. But yeah, after I do this, I think you're right about bundle install. Okay, I will attempt to run the application as it is right now. For that, you can either type Rails S or Rails start. Rails S, it's likely that will give me an error, right? So the first time you try to, the error is not because of the command itself. It's because I have to switch to the directory where my application is which is tickets app. I just created an application called tickets app, so I have to switch to the directory where the application is. So you see that there's a Git project, a Git repository. The command line is telling me that because I've got a special command line that is smart enough to tell me. So then I can run the server, and yeah, okay. So yes, now the commands that fj, ji said are necessary to be run. I can simply type here bundle install. Commonly, you just type bundle install and it fetches the necessary dependencies. Actually, I got most of the games installed, you know, so it will only download those that are not installed, those that are necessary that I don't have, right? Yeah, the error you're getting, the no such file or directory user being bundled, is because you don't have the bundler utility installed on your computer. So if you need to install the bundler, perhaps the command gem install bundler you could give that a shot. You could try that, gem install bundler. Actually, I got many versions of Ruby running on my computer. So I got an utility called RVM that allows me to select what version I want to use. So I want to use 261. And now I got many gem sets, many sets of dependencies available. So I'll pick the Rails lectures, which is the one I commonly use for this kind of examples. So, or I could create another one perhaps, but well, RVM gem set use Rails lectures. Here I can list the gems that are installed, and you see that there must be a gem called bundler. I got the bundler installed, and bundler is what you need to install for your command not to fail, like you show here. So I got bundler installed. To install bundler, you type gem install bundler. If I run that command, okay, it is installing bundler 2.1.4. If I look back on my list, I see bundler, but there's an older version installed. So it's good if you install bundler. You know, there it goes. If I list my gems again here, bundler should appear. There you got it. It's got now version 2.14, and before it there was 1.17.2. So you're missing the bundler utility fjji. If you install the bundle utility, then this other command, the bundle install command, should work. It takes some time to install for the first time. Some of the dependencies will compile C code, and that of course means running the C compiler behind the scenes. So it can take about a minute or two for some gems to compile. So after we create the blank application, we'll try to open it in the web browser and see what it shows. And then I'll show you how to create your first model. It's pretty boring, you know. You have to wait a little for it to install. Always, it's always the case. Well, in the meantime, I think just to be productive, you know, we'll try to create a model, to see how to create a model. Well, all models in Ruby on Rails are derived from a base class called ActiveRecord. Okay, this is the syntax for inheritance in the Ruby language. The class is called product, and it inherits from ActiveRecord. There are single inheritance in Ruby as it is with C#. So you won't be seeing multiple inheritance. You won't be seeing a list of classes here or anything like that. So if you got a product model, then you'll perhaps need a database table called products, right? And your table called products should contain then an ID, numeric ID that auto increments. The product can have a name, which is stored in a varchar 255 variable. And there's a primary key, of course, the primary key constraint for the ID attribute. So this SQL code here, this DDL code, you won't be writing any of this code, right? This code will be automatically generated for you when you ask Ruby on Rails to create the model. So if you got the model class and you got the database table created, then you can create a new product by using product objects. You call product new, then that will give you a new product object. You can customize the name, you can print out the name, and then you can save the product object to the database. It will be stored as a tuple on the products table automatically. So writing the class and creating the database table by hand is very inefficient and is prone to errors. You can mistype the names of things. You can forget a database constraint. You can forget, many details that can give you a lot of hassle. So Rails will provide a generator that is a script. It's basically a script or a set of scripts that will automatically generate the model you ask for, as well as the necessary database commands, which create the underlying table. And this is the command you run to create a model. Rails generate model. You give the name of the model in Pascal case, and then you give each of the attributes of your model specifying the type. It's got a string, a column called title, and another text column called text. So you got a generator that will simplify the process of creating the model and the database table. Right, it just installed the application. I can now run Rails S. Okay, so then we got our Rails application running for the first time. If you want to open this application and see what it is about, you can go to your web browser. Sorry about this. I've got plenty of clutter on my computer anyway. So localhost colon 3000. That's your web application running on port 3000. There it is. It's telling what Rails version we got, what Ruby version we've got. And if we look into the terminal, we'll see a request has been processed, right? We got a controller in our application that's called welcome controller. The welcome controller has inside, if you look into the code, it has an index method. The index method will render a view which is static. This view is static for the most part. The dynamic part of the view is that it shows the versions of the software that's running. Sure, if you're working with RubyMine, you should select the Rails application kind of project. There you go. So, of course, if you'd like to run RubyMine, you can do so. I can open it as well. So I can perhaps, it's scanning for Ruby interpreters. It should look for the 2.6 I got. Then I can open the project I just created. I can go to my code folder, then look for the web technologies course. I've got many folders. Here it is. It's ordered by date, seems. So here's class 3. Here's the tickets app. I can open this. And here's RubyMine. There you can see it's running with Ruby 2.6.1. So got my tickets app here. And let's make sure the dependencies are correct. Let's go to preferences. Go to languages and frameworks. Ruby SDK and GEMS. Yeah, so it's using 261. I'll switch to Rails lectures, which is the GEM set I use. It's likely that you won't be seeing something like this, being able to select the GEMS. You just select the version of Ruby you want to use, right? So then I can run the application from RubyMine like this. I can edit the configurations, and I haven't run this before from RubyMine, so I can simply run Rails here. Okay, so default server, port 3000. In Rails, we've got 3 environments for running an application. We've got the development environment. That's what we'll be using for the most part. The development environment is very verbose about the errors, very verbose about what's going on in the application. You'll see in the logging, in the log files of the application, a lot of information coming out, right? And you'll be able to run a debugger on your application and see where the errors are and so on. If you are running on production, then that information will be very limited, very scarce, because in production you want maximum performance, and as well for security reasons you don't want to disclose any of the internal errors or warnings that appear when you run the application, because that can be very helpful for hackers to exploit. So all right, we'll use tickets app. We'll run it with the default configuration. I can simply run like the application here like this. So the stuff I showed you on the command line, the stuff I showed you here, will appear now in RubyMine. RubyMine runs the application, in its own way, and it's got its own console. So there you got it. Once you see this line here, use Control-C to stop. That means your application is running. I can refresh the page. If I refresh the page, then, well, it shows me that there's an error here. I don't know why there's an error. Let's see. Run here. Yeah, there we go. Yeah, the error was meaningless. It is not related to the request I just sent to the application. You see, here I sent a request for the root path of the application. So you see there's a database query that got executed here. Select SQLite version. We're using a database engine called SQLite with this application, and a query was run at some point that took 2.6 milliseconds. There's a controller. I can walk you through the file structure of the project, right? Here you got the file structure of the project. You got a folder for the app, the application itself. You got a folder for controllers. Here's an application controller class that's empty. All controllers in your application will inherit from application controller. There's a model folder that contains also application record, which is the base class for all of your models. Note that it says it is an abstract class. This is the way we do it in Ruby. We tell a class is abstract by setting a Boolean parameter, a Boolean member, a class member that's called abstract class simply. So currently there are no models created by us. There are no controllers created by us. They're simply the skeleton of the application. All right. Yeah, that welcome controller is provided by Rails. Somewhere the files are stored. It's part of the Rails package, of the Rails gem. So we won't be seeing that code here in the application. All right. So if we'd like to create a model, we will do that now. I can just stop this, stop the application running. Got a terminal here. Can open the terminal. Yeah, got my terminal here, my terminal window. So I can choose either to work with a terminal on RubyMine or have my terminal window, separate terminal window running. I prefer to use this separate terminal window as it's larger. I got more space and it's easier for you to watch what I'm doing. So I got the application directory, I list what is in there, and I see the same file structure I get with RubyMine, of course. There's a command called tree. The tree command can show you all the tree that's below in the file system. Well, there are many files that are created nowadays by Ruby the first time you set it up. By Rails, I mean the first time you set it up, because there's, for instance, cache that gets created automatically for the images, for the scripts, for the files. So there are many directories with cache and cache items, and that takes a lot of space when you view the directory structure with a tree command, as I've shown you. All right, so how do we create a model? Very simple. We can create a model for a ticket, for instance. This is an application, an e-commerce application that will allow to sell and buy tickets for events, for instance. So we can run Rails G stands for generator model. So we will create a model called ticket, and the ticket will have a, I don't know, and some price, for instance. And the price will be of type integer, or can be numeric. I think numeric could work. Just give me a second. There you go. So recall that first you put the name of the attribute, then colon, then the type. Okay, it's easy to get mixed up at the beginning and put the type instead of the name. Put it in the wrong order. So mind about it. I mean, it's not that trivial sometimes to learn these things, because it all follows conventions. Okay, so you got first the price, which is numeric, then perhaps a description, which is string type. It has a price and it has a description. So it just told us what it's done, what it has done. It invoked some ActiveRecord operations. It created database instructions for to create a database table for the tickets. I'll show you that in a minute. It created a ticket model. It created tests, we could say amenities. We could say algunos como artefactos para poder hacer testing del modelo. Yeah. So if we go to RubyMine, back to RubyMine, and we refresh this, it refreshed automatically. We see there's a model called ticket, the one we created. You don't see any class attributes because the class attributes are inferred from the database columns. No estamos viendo atributos en ticket, no vemos que esté especificado, por ejemplo, como miembro, la descripción así, o algo por el estilo. Ya no estamos viendo una cuestión como esta. ¿Y por qué razón? Porque cuando se crea la tabla en la base de datos, las columnas en la tabla son automáticamente interpretadas por ActiveRecord como atributos del objeto. ¿Ya? Es como que todos los atributos se crean automáticamente dependiendo de las columnas que hay en la tabla de la base de datos que corresponde. ¿Ya? So, okay, very good. If I now attempt to run the application, Rails will give me an error, okay? Rails will yell at me. It should yell at me at least. Should say something. And if it doesn't say something, well, it's kind of strange. All right. Let's see. So if I refresh this, the application is supposedly running? Yeah. Okay. The application runs, but once I ask for the root path, or if I try to interact with the application for that matter, it will tell me pending migration error. What's that? What the heck is that? Pending migration error. So to understand what a pending migration error is, I have to tell you about a thing in Rails that's called a migration. Okay, so after running the model generator, the following items will be created, and we've seen that. A model class got created, a model tests, objects got created, and finally a migration got created. So a migration is an ActiveRecord class that will perform incremental updates to the application database. That means that the application database has not been updated with the new table that is necessary to hold the data from ticket models. The database for the table for the new model has not been created yet. So to create the table, we need to run the migration that got automatically created for us, and many other possible migrations that might have not been run already. So a migration is a class that tells ActiveRecord what operations to conduct on the database. So migrations are a way to alter the database schema over time in a consistent and easy way. It's a way that's easy for us to track. It's easy to track the evolution of the database schema. So below we see a migration called create products. You see that create products is a class that inherits from ActiveRecord migration. It has a method in within that changes the database, right? So the change to the database is by creating a table called products that contains a column named string of type, a column or named name of type string, and a column named description of type text. And it's got the timestamps, the created at and updated at columns as well. So each migration will apply this kind of operations to the database schema. These operations, such as create table, are written in a Ruby idiom. It is what it's called a domain-specific language. Create table, update table, well, alter table. Well, there are many different possible we could say commands that you can put inside a migration to alter the database structure. Here you see another pair of examples. So we got a migration that is reversible, explicitly reversible. That means that the migration can be applied to modify a column in a table. For instance, we're changing table products, and when we apply the migration in a forward direction, in an up direction, it will change the column price to string type. If we reverse the migration, it will roll back the change and have that column with integer type, right? So you can undo a migration and redo a migration if you will. You can apply it for the first time and then reverse it, and you can have the migration tell what to do in each case. Okay, so one way of specifying that is like the example above. Another way is like in the example below, in which you have separate methods in the migration that apply the change and reverse the change, up and down. Right, so migrations are Ruby classes that inherit from ActiveRecord migration. The corresponding migration files are stored under the db migrate directory, and we'll see that in a minute. Migration files, by convention, should be named as follows. You got a timestamp first, then you got a migration, and then you got the class name in snake case. It's all in snake case. As I told you, the folders and files in a Ruby on Rails project are named with snake case. Get accustomed to snake case. So the name of the migration class will be in Pascal case, and it must match the name of the migration in the source file, which is in snake case. So let's see the migration that got created for the ticket model. We can go here to the ticket, to the DB directory, sorry. Here's the DB directory, and we've got a migrate directory below. Look at this. 2020, we're in year 2020, in the month of March, the day 27th, and this is the number of seconds that have elapsed, I think, since midnight, I think, no? Could it be that way? 25,000. Yeah, well, the day has 86,400. It can make sense. It's been like 10 hours or so, no? It doesn't seem to be right. Yeah. Well, it's time anyway. It's time in seconds. Should be time in seconds. So we're creating a table that has a price, which is numeric, and a description, which is a string. Okay, it's as simple as that. Then there's, yeah, well, this seats file will cover that later. This is the database file which is based on SQLite. SQLite as the database engine. You can change that to Postgres or to MySQL or to whatever other kind of relational database you want to use. Anyways, SQLite is very useful for development, comes in very handy because you don't need to configure almost anything. It will just work. So let's see. Let's try to apply the migrations. How do we do that? Okay, there's a command called rake. Okay, rake is simply a sort of a task runner, if you will. So you run the task called rakedb migrate. It is important though to specify which environment you're working on, right? So Rails env equals development, and then you run rake with the db migrate option. That will run the migrations that are pending. So there we just ran the migration. It created a table called tickets with the columns we asked for. I'll see in the chat if we got any questions at this point. I installed it, but the load error persists with the bundler, you mean? Yeah, okay. So when you type Rails new something app, you get the load error persist. Well, I need a little more details. I understand that you're running Ruby 2.5, but you have to still tell me you're running this on Ubuntu, right? I can infer from the path you're putting here that it's either Ubuntu or another Unix-based systems. Could even be a Mac, maybe. So you need, I need some clarification on what system you're using in order to help you with the load error. Professor, I get an error. I could not locate gem file. Okay, what's the gem file? What's the gem file? If you're getting an error about the gem file, well, you see I just listed my files in the tickets app, and there's a file called the gem file. If you open that file, for instance, I can edit it on my terminal with a program called Nano. Or, well, Nano is a text editor that runs on the command line, like this, you know. So you can see the contents of the file, and you can even modify the file if you need, but I won't be changing anything. So this gem file tells what the dependencies of the application currently are. You know, you got dependencies here specifying what's the database, what's the version of Rails you'll need to be using, etc. So if you're getting an error about the gem file, that can possibly mean that you're not in the directory that contains the gem file. You can type ls or even dir, I think. No, dir doesn't work in my terminal, in my CSH. So on Windows, if you're running Ubuntu on Windows, well, ls will work. So the gem file should be there present. If it's not, then perhaps you are in the wrong directory. To see your current directory, you type in present working directory, pwd. It is telling me the current folder I'm in, right, in the terminal. Okay, you're using Windows with Ubuntu on WSL. Oh, that's good. All right. I'll get back to you, in a minute. I'll keep that in mind. I'll look for a solution. But as for now, I need to show you the following. If you run Rails S, you will run the Rails server or the available web server by which you can open the application on your web browser. There's another Rails option, which is Rails C. Okay, Rails C will open up the Rails console. So you're running here, we're running the Rails console with the development environment. And what we can do now is to create a new ticket, for instance. We can create a ticket like this. We can say the price is, I don't know, the price is 10, and the description is a cheap ticket or something like that. So then we got a ticket that's created, okay? If we type in the name of the object, it will tell us it doesn't have an ID yet, okay? This object doesn't have an ID. That means that the object is new and hasn't been yet stored in the database. The price is 10, and it's being stored as numeric with the decimals. So it's 0.1 to the power of 10 to the second power of 10. 0, 1 times 100 basically. So the description is a chip ticket. It was created at, well, it hasn't been stored in the database, so this field is nil as well, and updated at is also nil. So if we want to store the ticket, we simply call the save method. Yeah, I'll show you about this in the next class, more details about the subtleties there are when you save. So okay, now the ticket got saved. And if you see, it now has created at and updated at attributes. It should even have an ID as well. It has an ID. You see, now the ID is 1. If I type T, it will give me the ID, the price, the description, the created at. So if I want to get all the tickets that are available, ticket.all, those are all the tickets there are. It's returning a relation that is we can think about it as a list of ticket objects, you know. So in the console, you can try all of these things. You can try to create a model, you can try to save the model. If we'd like to change T, for instance, if we'd like to change the price you want it to be 20, okay, then you can just save it. You can ask what the T object contains, and now it's 20 instead of 10. So it's very intuitive to use. The query interface from ActiveRecord. We'll look at it into more detail later on. So the last topic I need to show you about is associations. Associations is quite a topic, quite a long one, I think. So we'll still be covering this next class, the start of next class, showing you more in-depth associations, examples, and things. So an association is a connection between two ActiveRecord models, commonly, you know. So why do we want associations? Recall the case in which you got a relational database and you want to select you want to select from two tables through a join. You know, you can have an inner join, an outer join, etc., etc. So you write SQL statements for that if you'd like to perform a join, for instance, right? And that's because one model or one entity in the database is related to other entity in the database, and there's a foreign key relationship of some kind, you know, that allows you to join between the two tables. In the case of Ruby models are objects. So these objects of different types can be related together. For instance, I can have an order for tickets. If I want to purchase tickets on my tickets application, then I'll need some order that contains the different tickets I purchased, right? It makes total sense. So for that to happen in the object world, in the world of Ruby objects, in the world of ActiveRecord objects of models, then we need to provide some way in which we can relate these objects, and these are the associations about. This is what associations are about. So there are many association types depending on how you want to link models together. You know, we got the belongs to association. That means that one model naturally belongs to another one, right? For instance, I can have a ticket, so the ticket belongs to me, right? It makes sense. Or the ticket belongs to an order, right? There can be, depending on the cardinality, you have to see the other side of the relationship. You know, if you got something that belongs to another entity, then that entity may have one or may have many, you know, of the containing objects. You got another association that has many through and has one through. That's sort of an indirect kind of association that it's best to see with examples. For instance, the classic example for has many through is when you got patients and you got appointments. You got patients, you got appointments, and you got doctors. So the patient relates to a doctor through an appointment, for instance. You can do that. And finally, you got an association called has and belongs to many. There's something that's badly typed here. This has to be lowercase. There you go, to be consistent. Has and belongs to many is the classic end-to-end relationship among two models. You know, you can have, I don't know, a person that owns many, or a person that has let's think about something usual, common, oh my gosh, something that can be shared among many people, and then there can be many instances of this object. Oh well, kind of hard to think about an end-to-end this morning. I'm not that awake still. But the end-to-end, it's quite likely that you've used it previously in your database course anyway. The end-to-end, you implement that with has and belongs to many. So okay, we'll try to show you a quick example on associations. Okay, Control C or quit. Quit. So you quit the console with just with typing quit in there. So if I go to RubyMine, all right, I'll need to create another model called order, for instance. So Rails generate model order, right? And well, the order will simply contain tickets, right? So actually, the ticket will belong to an order, so the foreign key to order should be in the ticket, not in the order, right? So I'll simply create an order, model empty. There we got it. Let's see the history. Let's find the rake command I just typed. Sorry. I'm showing you some terminal shortcuts you can take. Instead of typing things all over again, you simply run the command from the history. So I'm creating this order, right? This order table or entity or model. So now I'd like to relate the ticket to the order. For that, I need to add a column, a foreign key column to tickets, to a ticket. So Rails G migration. So we're creating a migration with this. So it would be add order ID to ticket. I'm following a convention because this is an automatic way to create migrations. And this command will allow me to add an order ID to ticket. I think this will be enough. Let's see. Just to be sure, You can always look up these things, foreign keys. You just Google, and you get to the documentation quickly. Yeah, well, this is showing me how to specify the migration by hand. There's I'd like to see the automatic way of doing it. There it is. I got it. So for instance, we're seeing here the search result. This one, migration at post to comments, post references. That's exactly what I was looking at. Sorry. All right, so very good. You see here, generate migration at post to comments, post references. In order for it to be a foreign key, you have to specify that the post will reference comments. In this case, the ticket will reference order. So it's ticket, add order to ticket. Sorry, it's order references. Yeah, there's like a mnemotechnia to remember this. When you add the column, add post. In this case, is add order. So order is what you should put next. There you go. So if we take a look at the migration that gets generated, there we got create orders. Then we got add order ID to ticket. There you got it. Add reference. Okay, the table name is tickets. It will reference the orders table. It's a foreign key. So if we now run the migration, RakeDB migrate should work as well, you know, without need to specify the development environment, I think. Let's see. Yeah, it's giving me an error, you know. It's not too friendly, the errors. Okay. SQL exception. Cannot add a null column with default value null. So, okay, the default value is null in this case. Let's see. It can be nullable. It can be nullable, you know. I just changed the null attribute there to make it nullable. Sometimes it's kind of hard to see what the errors are. You got it. Okay, so just to finish the class, you know, I'll show you how to use this association. So now we got a ticket in the database, a single ticket created. We'll create an order. Sorry. There you go. So we got an order now. There's an order. Now we'd like to take the first ticket. There we got the first ticket in the database, which is the single one that's present. So t.order is order.first. Actually, sorry, we got the order here in variable O. We got the ticket in variable T. So we can say ticket.order equals. Yeah, well, this doesn't work. And why doesn't it work? Because we haven't defined association yet. And this is the last part I'd like to show you. So ticket belongs to an order. Okay? And then you have to go to the other end of the association, and you have to put here that the order has many tickets. There you go. So we'll have to quit. We'll have to run this again. And now, okay, O is order.first. Then we got T is ticket.first. Okay, T.O equals order, equals O. And then we got it. So if we call now the ticket, the order to which the ticket belongs is order 1. You see? So automatically we can get t.order and it returns the order to which the ticket belongs. So all the associations allows the objects to interact amongst each other, you know. I can attach an order to a ticket, ask the ticket for the order, I can save the ticket now. Okay, so perfect. It all sort of fits together now. Very good. So there's there's something else about ActiveRecord, which is the query interface. This will allow you to perform queries on the models. I just show you a very simple query, which is for instance, the all will give me all the records, right? But there's another method that's called find, and you can find putting here criteria, much like a SQL a clause, a select clause, you know, select from database where. So the where condition, you can put it in a find statement, in the find method. So there are many guides that at some point you'll need to study. This guide will show you how to find records using a variety of methods and conditions, how to specify the order. So it's like learning SQL again, but using a query interface that's written with Ruby language. So here, for instance, client find 10, it will look, the equivalent SQL statement is this one here. You know? So it's like Ruby statements will translate to SQL statements using the query interface that is provided by ActiveRecord. So for next week, I suggest you do the following. Study this class again thoroughly. Study the Ruby language, get acquainted with the Ruby language. There's this tutorial, which is interactive, and exercise by exercise, you'll be gaining practice with the Ruby language. then you should read this guide about the ActiveRecord basics, which is what I've shown you in this class. And lastly, read about ActiveRecord migrations, which is also another guide that it's available in the guides.rubyonrails.org website. So, okay, these are the basics in ActiveRecord. I've shown you already much of this documentation. This will tell you how to perform CRUD operations on records, on models, how to include validations, though that's more advanced and we'll cover that in a couple more classes. It will tell you about migrations. So the basics and the migrations guide as well. Understand migrations, how do they work. So in the next lab, you'll start off working with a basic Ruby on Rails project, and you'll be adding models and associations. That's what we'll do in the next lab next Thursday. And in the second part of your first project assignment, you'll be implementing the data layer, the model layer for your application. So this, I think, responds to Jose, a recommendation to study all of this. Well, I got here the recommendations for you. It's best that you first start practicing Ruby and you get acquainted with Ruby on Rails. You can watch this class again and attempt to run the same commands I just did. Get your first application running. Try all that. Be prepared for the next lab, because in the next lab you'll be actually coding with Ruby on Rails. So now it's 10:25. I think I went a little longer than I planned. But anyways, I thank you for watching, for attending this class. You'll have the video in YouTube forever available. So please head to the video that's left in YouTube if you got any questions, okay? Have a good day and see you next week. Goodbye.